So I'm going to go ahead and just clear my calculator first. So second plus 712, I'm just going to clear my calculator. Okay, so the first question on here is asking where the two graphs are crossing each other. And we have a cubic graph, that is f of x, and a square root graph, that is g of x. And can you guys tell which one is which? We have a black graph and a gray graph. Can you tell which one is which just by looking at them? Yeah. So which one is the black graph? Is it f or is it g? It is f, yeah. F of x is the black one. And g of x is the gray one. You can tell by the shape. So if it asks where they equal each other, it's asking where they intersect. Now, it looks like they intersect at this nice point. It looks like they intersect at -2, -5. But we always need to use the calculator to be sure, because it could be like those exact numbers, or it could be decimals that are just really close to whole numbers. So what we're going to do is we're going to plug both of those equations in and use the calculator just to make sure. So 1/3 x minus 1 to the third power plus 4. And then square root x plus 6 minus 7 okay, and then we're going to go ahead and hit graph. Right, so if we want to see where they equal each other, we need to see where they intersect. We need to find their intersection. And the way that we do that on the calculator is we hit second trace. So second trace is where you often go to find the menu of different things the calculator can do. And intersect is number 5. So we're going to go down to number 5. And whenever I do this, if there's only one intersection that you're looking for, you do not have to move the cursor closer to the intersection. The calculator knows exactly what intersection you're talking about. The only time you have to move the cursor is if you have more than one intersection and you're trying to tell the calculator which one you want it to find. So since there's only one intersection and it's right here, all you have to do now is press enter, enter, enter. You press it 3 times. So enter, 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 and the calculator will go right there and it'll tell you what the point is. So for this one, it looked like it was a whole number, -2, -5, no decimals. Does that make sense? How we found it? Okay, so -2, -5. Where does f of x equal g of x? Now, we can answer this question as a point. That would be a good answer for the question. Or, because it's phrased as a where question, what coordinate do you use to answer a where question? The x coordinate. So the other way you could answer it is you could say at x equals -2, and you could leave out the y coordinate completely. Okay, and that's because they're asking you a where question. Okay, if they said what value makes the two equations equal to each other, then you would say the value that makes them equal is -5. Where does it happen? It happens at -2. What makes them equal? -5 makes them equal. All right, which function has the greatest x-intercept? It's not asking you to find it. It just wants you to say which one is the biggest. So if we were to compare, f of x is over here, g of x, if I follow the path of g of x's x-intercept is like somewhere over here. So which x-intercept is greater? Which one is bigger? G of x is definitely bigger. I don't even have to find it to know that. Okay? Where is f of x bigger than g of x? What does that look like on the graph for f of x to be bigger than g of x? How do I know that f of x is bigger than g of x? They're equal here. When f of x is above g of x. So up here, these are when the f of x values are going to be higher than the g of x values. And you can tell just by touching it with your pencil, right? If I go up here to g of x, I'm literally going up here to g of x. I have to go up. I have to go higher to g of x, so it's bigger. Or sorry, I have to go up to f of x, so it's bigger for f of x. Does that make sense? I have to go down to g of x. So all of these values right here are the values where f of x would be higher than g of x. So it says where is f of x greater than g of x? Since it says where, I'm looking at the x values. So they are equal at an x value of -2. And then for all of these x values, all the way to a right arrow, what number is a right arrow? Positive infinity. So for all of these x values here, f of x is higher than g of x. -2, -2, all the way to, how do I write that answer? -2 infinity. So the answer that I just wrote is I'm saying that f of x is higher than g of x starting at -2 going all the way to infinity. That's the portion of the graph where f of x is bigger. Now it says greater than or equal to g of x. So should I put a parenthesis here or a bracket? Am I including -2 or not including? I'm including -2. Okay? So f of x can equal g of x, which is what's happening at -2 exactly. What do I always put around infinity? Parenthesis. I can never include infinity because I'm never actually going to get there. Okay? Where are both functions increasing? So this is just saying where is the stick figure walking uphill for both functions at the same time? So if we look at f of x, what do you guys see about f of x? If you have a stick figure walking, he's going up the entire time, okay? What about g of x? If you have a stick figure walking, what is he doing? Up the entire time. So let's just write the increasing answer for each of those. So f of x, g of x. F of x, the increasing interval is a left arrow to a right arrow. How do we write that answer? -infinity to positive infinity. G of x is not a left arrow to a right arrow. It's a point that stops. So what's the point here? -6 to a right arrow. And actually, this one's kind of interesting right here, because if you have the stick figure starting right there, if he starts at -6, is he actively walking uphill at the -6? Yeah, he's actively walking uphill. This is the first time for increasing or decreasing that we've ever had a bracket. If you put a parenthesis there, this is like the only time in math where it should be a bracket, but if you put a parenthesis, nobody will mark you down. So it's acceptable here to put a parenthesis, but a bracket is more correct. So he is walking uphill right there. But if you put a parenthesis, I'm not going to mark you down. Okay, so he's walking uphill, and then the other one's uphill the whole time. Okay, so we have two answers. This one is you're walking uphill forever. I'll take it. Thank you. The other one is we're walking uphill, but we're only starting at -6. Are these answers the same? Not quite, right? I'm going to say that this is similar to like you're hosting, let's say you're a college student, you're hosting a dinner party. You have one friend that literally eats anything. They're like a Hoover vacuum cleaner. You put it in front of them, it's edible, they'll eat it. The other part is, let's say you have a friend and they are vegetarian. So if you were cooking for that friend, what food would you make? You're cooking for you and that friend and some other friends. What kind of dinner would you make? Would you make just anything? No, what would you make? You would make vegetarian. You would default to the person who has the more limited diet. Does that make sense? So if you have friends who can eat anything and one friend that's vegetarian, the vegetarian friend wins. The more limited answer wins. Does that make sense? So if this person walks uphill forever and this person starts at -6 to walk uphill, -6 starting point, that one wins. So if we put these two answers together, we're going to say our increasing interval is from -6 to infinity. Okay, how do your brains feel about that? Did that kind of make sense? Is there any part that needs to be re-explained? No? Let's graph this one. So before we graph it, we need to find the locator point. It doesn't have a vertex, so it has a locator point. So what is the locator point? 3, 2. Okay, so over 3 up 2. Okay, then I'm going to go ahead and graph it on my calculator. So we got square root x minus 3 plus 2. Okay. And I'm going to hit graph. And we know that square root graphs are kind of the weird ones. They have the starting point, that locator point is where they start. And then these are the only graphs that don't go back and forward. They start at the point and then they only go one direction. They do not go backwards. So I'm going to look at the table and I'm going to look for the point 3, 2. So I can't go backwards. That's where all the error messages are. I can't graph that at all. But I can go the other direction. So I've got 4, 3. And then I'm going to skip the decimals. 7, 4. And then I think that's the only thing I can fit on my graph. Yeah, 12, 5. That's not too far off the graph. Okay. So to get the chart, you do second graph. So my graph starts at 3, 2, and it goes like this. Okay. I already messed up a little bit. Does anyone see how I messed up? It should be dashed. It should be dotted. Because of the symbol, this is an inequality, and it should be a dotted line. So I'm going to go back and erase a little bit of mine to make it dotted. That looks kind of dotted now. Okay. So, dotted line. Okay. All right. Now, the reason this was a challenge problem is because when you shade this one, it's kind of confusing to shade. So if it was a straight line that went across the whole graph, we could shade like above the line or below the line or to the left of the line, to the right of the line. If it was a V or a U-shaped graph, we could shade inside of the V or outside of the V, inside of the U or outside of the U. If it was a cubic graph, we would have, that would go across the whole thing. We could do one side or the other. This is not like that. You guys see how this is not like that? We don't really know what each side is. What we do know, though, is that the numbers over here gave error messages. Does that make sense? They gave error messages, which means that when we consider this graph, I have to cover this up, my shading cannot go over here at all. No shading above, no shading below, no shading at all, because those numbers couldn't even get plugged in. Does that make sense? No shading, none whatsoever. So when I shade, I have to pretend that that part of the grid isn't even there. Does that make sense? Because those numbers can't exist for this graph. They don't work. Including the negative y values. So the only part of this graph that I can shade is this part up here or this part down here. So if I wanted to be lazy and use the point 0, 0, I can't, not for this graph, because 0, 0 is not included. Everyone see that? All right, so what point do you guys want to plug in? 4, 4? Is that what you said? 4, 4? Yep, 4, 4 is right up here. Okay, so let's plug in 4, 4. 4 for x, 4 for y. 4 is greater than square root of 4 minus 3 plus 2. That's a great point to plug in because it's pretty easy. 4 minus 3 is 1. What's the square root of 1? 1. So 1 plus 2, 3. Is it true that 4 is greater than 3? That is true. Okay, so I'm ignoring all of this. We know that the point that's above the curve is true. That means the stuff below the curve is false. And so I'm going to shade above. But I'm not going to shade anything to the left because that stuff is where the error messages were. So this is the only part that I can shade. So that's what the shading is going to look like. Does that make sense? Okay. That's not going to be on a test. That's not going to be on the EOC. That's a great bonus question, though. Just because it's kind of like, oh, do you understand how this works? It's good. It's good for conceptual understanding. Okay. Go ahead and make sure that you have that stuff done. Well, actually, before we turn this in, were there any other questions on here that made you feel confused? Yes. Okay, 19 and 20. Okay, so 19 is a cubic that has a negative sign in front of it, so it looks like this. 20 is a cube root that has a negative sign in front of it, so it looks like this. Okay. All right, so if we had a stick figure, so we're doing our increasing and decreasing. If we had a stick figure, and the stick figure is walking on this one, is the stick figure walking uphill or downhill? Downhill, and downhill the whole time, right? So for this one, for increasing, we would say none. And for decreasing, we have to do our x values. So what is the x value for a left arrow? Negative infinity. What's the x value for a right arrow? Infinity. So our decreasing interval is negative infinity, infinity. Yes. Okay. Over here, if we put our stick figure right there, if he starts walking, is he walking uphill or downhill? Downhill, straight, but it would be slightly downhill. You guys know when you're like a little kid and you're riding your bike, and it doesn't really feel like you're going downhill, but it's like kind of easy? That means you're going downhill, right? Or if you're riding your bike and it doesn't look like you're going uphill, but it's like kind of difficult, that means you're actually going uphill. It's just like a very slight incline. So that's kind of what this is. It's a slight decline. It's just not very steep. So decreasing, what number do we put here? Negative infinity, because it's a left arrow. What number do we put here? Positive infinity. So for increasing, we're going to say none. And for decreasing, we're going to say negative infinity to infinity. So this is the first time that we've seen that for increasing or decreasing, none is a valid answer. And that's definitely possible on these. Were there any other problems where the answers were kind of funky? Anything else that stumped you? Nope. We're good? 16. So domain, range, and the intercepts. So this is an absolute value. That's a V-shaped graph. So for domain, we're going to go from left to right. So the left side of the graph is an arrow, the right side of the graph is an arrow. So negative infinity to infinity is the domain. The range is from the bottom of the graph to the top of the graph. So what number would we use for the bottom of the graph? Negative 9, because that's the y coordinate of the vertex. And then what number would we use for the top of the graph? Infinity, because those are arrows going up. So we would say negative 9 to infinity, so the bottom to the top. The infinity always gets parentheses. And then what about the negative 9? Bracket for that, because you can put your finger on it. Okay? And then if I do my intercepts, 1/2, I need the vertical line, so I'm going to hit the math button. Go over to number. I have x plus 5 with a minus 9. So both, I know that there's going to be x-intercepts there. I can see that it's going to cross over here, it's going to cross over there. I just can't see what they are. That means that I need my x part of my window to be a little bit bigger. So what I do is I press the window button. And this is actually good for everybody to practice, so I want everybody to type this one in. So 1/2, absolute value. You hit the math button, and you go over to number. Go over, so right arrow to number, and it's the first one. Mm-hmm. All right, do we have this graphed? Yes? Okay, so we can all see that it's too wide for our picture. So what we're going to do is we need more to the left and right. That's more x values. We're going to hit the window button. And we need bigger numbers for the x min and the x max. So I could try like negative 15 and positive 15. So I'm just changing those first two numbers, x min and x max. I'm just making those numbers bigger, negative 15, positive 15. Then I'm going to hit graph again. So positive 15 was good. Now I can see that one. Negative 15 wasn't quite big enough. So I'm going to hit the window again. And I'm going to make negative 15 bigger, so like negative 20 maybe. And I can see negative 20 wasn't quite big enough either. So maybe like negative 25. Just barely big enough. Now, if you don't like them being really close to the edge like that, you could make them even bigger. So negative 25 was barely there, 15 was barely there. You could do like negative 30 and positive 20. And that would be definitely big enough for you to see everything. Okay, so now to find the actual x-intercepts, we're going to do second trace. And option number 2 is how we find the x-intercepts. So I know that I made my window go to negative 30. So if I'm being lazy for me to find the first x-intercept, I could tell my calculator to look between negative 30 and 0. Because I know that the answer on the left is somewhere between negative 30 and 0. So I'm going to do left bound as negative 30. I'm going to do right bound as 0 because I'm being lazy. I don't feel like figuring out a good estimate over there. And it looks like one of the x-intercepts is at negative 23. So x-intercept, negative 23. Okay, and then I'm going to do second trace, option number 2. On the other side, I went to positive 20. So for this one, to find the one on the right, I'm just going to tell my calculator to look between 0 and positive 20, and it will find it just fine. So I'm going to type 0, enter, 20, enter. Whenever it says guess, I always press enter. I never look at the guess. And the other answer is 13. Were you guys able to find those? Yeah? Okay. Does anyone remember how to find the y-intercept? Second trace, number 1 value, plug in 0, yep. So 0, negative 6.5. Perfect. Okay. Okay. Any other ones that we were confused on? They made sense? We got them? Okay. Let's go ahead and get this assignment turned in, and then we need to get out our piecewise notes. Did I do both examples or just one? I did both? Okay. So go ahead and get out your piecewise notes, and then get out a pencil. So get out piecewise notes and get out a pencil. Okay. So number 5 has x plus 2 squared. I'm going to put a 0 on the end because there's no number on the end. Can somebody tell me what the vertex is for this? Negative 2, 0. Okay, so I'm going to graph the point negative 2, 0. And then I'm going to go ahead and grab my calculator and type in x plus 2 squared. I'm going to look at the table. I'm going to look for negative 2. So there's negative 2, 0. And then I'm going to make sure I've got some more points graphed. So negative 3, 1, negative 4, 4. And I actually have enough space on this one to do even more points. So I'm going to do 3 points on each side just because I've got room. So negative 3, 1, negative 4, 4. And then I can actually do negative 5, 9. Nope, I can't do negative 5, 9. Just kidding. I thought my graph went to 10. It only goes to 8. Okay, so I can do negative 1, 1, and 0, 4. Okay. So there's my graph. Okay. So now that I have the graph, I'm going to find the point on the graph where the x value is negative 1. And that's right here. And I'm going to circle that point. Okay? Now, based on this symbol, is that circle filled in or not filled in? Not filled in. Okay? And then the arrow on this is pointing to the left. So which part should I keep? The left side. So I'm going to make the left side a little bit darker because this is what I'm keeping. So I want the person who's looking at my paper to be able to see it clearly. I'm making this dark. I'm putting an arrow on the end. And then the right side I'm going to erase. Okay? We feel good about that? Okay, the other part is g of x equals 3. G of x is another way of saying y. Y equals 3. So the other equation we have is y equals 3. Does anyone remember what it means when we see equations that look like this? Say it again. They're horizontal lines. They mean that you're choosing a line where every single point has a y coordinate of 3. So we have the point like 0, 3, 2, 3, 3, 3, 5, 3, 8, 3, negative 4, 3, negative 6, 3, -7, 3. That's why it's a horizontal line. So we're going to go ahead and draw that horizontal line right there at 3. And then we're going to find where the x value is -1. And we're going to circle it. And should we fill it in or not fill it in? We should fill it in. And this arrow points to the right. So what should we do? Keep the right side. Make that side nice and dark so you can see it really well. Keep that side, and then the left side needs to be erased. Done. And then you know that your graph is more than likely correct if you can take your pencil and do what we call the vertical line test, and your pencil should not touch more than one point at a time. So if you have pieces of the graph that are on top of each other, that means you did something wrong, okay? The only points that I have on top of each other are the hole from this graph and the filled in piece from that graph, and that's okay. But I shouldn't have a curve here and then a straight line there or something like that. They shouldn't be on top of each other, okay? Because that means they're not functions. All right. Is there another one that looks intimidating? We can turn to the back of this page too. So we got 1 through 6. Oh, that printed weird. 1 through 6, 7 through 12. Is there one on that page that looks intimidating? $10? Let's do number 10. Okay, so number 10 would be x plus 0 plus 1. And what would the vertex be for number 10? 0, 1. Okay. So here's 0, 1. So I'm going to hit the math button, go over to number, absolute value of x plus 1. And I'm going to look at the table. There's 0, 1, -1, 2, -2, 3, -3, 4, -4, 5, -5, 6, -6, 7, -7, 8. I have a lot of points on there. And then I'll go the other direction too. So 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8. Okay. And where should we put our circle? Where x is -3. So here's -3. I'm going to circle this. Should I fill it in or not fill it in? I'm going to fill it in. Okay. And then should I keep the part to the left or keep the part to the right? Keep the part to the left because the arrow points to the left. It's all the stuff that is less than -3. Keep that. Erase over here. Okay. All right, the next one says square root of x plus 2. There's nothing on the end, so I'll put a 0 on the end. So it's not a vertex, it's a locator point. what would the locator point be? -2, 0. Okay. So I'm going to write -2, 0. And then we'll go ahead and graph it. This one gets a little weird. What gets a little weird about this one? Yeah, this graph doesn't even go to -3, but I'm supposed to circle it on -3. But it doesn't actually matter. What part of the graph am I supposed to keep? To the right of -3. So the graph doesn't go to -3, but I'm supposed to keep everything to the right of -3. So this graph starts at -2. Is -2 to the right of -3? Yes. So if I keep the entire graph, am I keeping stuff that is to the right of -3? Yes. So on this one, I can just keep the whole graph. I don't have to erase anything. So that was a weird problem, but it worked out okay. All right. Do you guys feel like you know what to do? We graph it. We circle the number. We figure out what to keep, what to erase. Make sense? Do you have to draw it each time and circle the number and then erase? No. When people get better at these, they start to not draw the whole thing. They start to only draw the part that they need. It's fine for you to get to that point. Okay? That's totally fine. All right. When you get past that, this next page, this is not number 1 with 4 different problems. This is number 1 with 4 multiple choice answers. So you are matching the piecewise equation with the graph. That's what you're doing. Does that make sense? Okay. So there's 2 problems on the front side, 2 problems on the back side. There's only 4 problems on that page. It just takes up a lot of space. Okay? All right. Go ahead and get started.